let's take a look at power in a hypothesis test. Now power is 1 minus the probability of a type 2 error. It's the situation where you try to prove that the alternative hypothesis is true. You try to reject the null hypothesis and do so correctly. If in fact the alternative hypothesis is true, if the null hypothesis is ever false, then you have two possibilities. You can either correctly reject your null, because we said the null is false, the alternative is true. You can correctly reject the null, or you can make a type 2 error. You can fail to reject when you should have. Those two things, in which case we're going to call this thing power, these two things add up to 100%. So we're going to look at where that all comes together. Probability of this is power. Probability of this type 2 error, we would just call that beta. And we say power is equal to 1 minus beta, or beta is equal to 1 minus power. If you do the algebra on this, basically what we're just saying is this section plus this section is going to add up to 100%, or 1 in the probability world. But again, these two formulas down here are two formulas you might just want to write down somewhere and can reference later. Now, how do you get power? There are a few different ways, but the best of those is to get a bigger sample. If you want to get more power into your data, into your hypothesis test, the bigger the sample you can get, the better. And in general, in statistics, almost everything gets better when you have a bigger sample. So bigger samples is always a really good way to get more power. Another one is to look for a larger change in your data. Let's say that you are studying the number of hits per game in baseball. Your goal would be to not just look for a very small change of 0.1 hits per game, but if you're looking for a difference of 1.5 or 2 hits per game, you're going to be much more likely to pick up that difference with your tests. So depending on what kind of changes you're looking for, you're going to give yourself more power or less power. Last thing is changing alpha, making alpha larger. Because if you make alpha larger, that means that you increase the chances that you're going to reject, period. If you want to give yourself more power, then you want to reject more often, and that will allow you to correctly reject more often. Skipping down to some examples here, I have a study with power of 80%. What is the probability of a type 2 error? Here we only have power and type 2 error going on, and we know our formula says that a type 2 error, beta, is equal to 1 minus the power. So if the power is 80%, we would probably rewrite that as 0.8, so 1 minus 0.8. And that's going to be 0.2. So the probability of a type 2 error in this study is just 0.2. I have a study with power 70%, and I know the effect size I am looking for. It cannot change. Alpha must be 0.05. That can also not change. How do I get more power? Your effect size is set. Your alpha value is set. The only thing left to do is to make n become bigger. You need a bigger sample size. The more you have in your sample, the more you'll be able to get that statistical significance you're looking for. Next one here, I was told that I'll be sampling 40 people. I calculated a power of 60%, but I need to get it to 80%. So you were told how many people are going to be in your sample. You were told your power, but you need to get your power to go up. Alpha has to be 0.05. What will you need to do? Now, it looks like your hands are pretty tied. You can't get a larger sample because your sample size is set. You can't cheat and just change alpha here because alpha is also set. The only thing you can do is look for those larger changes in the data. But even that's not fully under your control once you're up and running with a study. So in this case, this person is kind of out of luck. This thing that says that I am told I'll be sampling 40 people, this person's probably going to need a petition to get a larger sample size because it's going to be very tough to make it work. That's it.